All right, today we're reviewing the interior and exterior angles of polygons. It's just kind of a summary follow-up to the video you saw yesterday and the practice we did. So the essential question, how can you find the sum of the interior angle measures and the sum of the exterior angle measures of a polygon? So just like we discovered yesterday in our activity, and if you watched the video, I think the presenter did a good job of showing you the triangles. There is this standard formula. The sum of the interior angle measures of a polygon with n sides will always be n minus 2 times 180. And remember, that's because you can create n minus 2 triangles. So n minus 2 triangles times the 180 degrees that would be in each triangle. So we can go ahead and just look at some examples of doing this. Find the sum of the interior angle measures of the school crossing sign. Well, this school crossing sign is clearly a pentagon. If you count, there are 1, 2, 3, 4, 5 sides, right? It's a pentagon, 5 sides. So I look at the formula, n minus 2 times 180. Well, 5 minus 2 gives me 3, and 3 times 180 is 540 degrees. So it doesn't matter that it's a school crossing sign. It's just a sign that's in a shape. It's a pentagon. So I'll apply the same polygon rule. So here are two more examples. Find the sum of the interior angle measures of the green polygon. And this kind of stuff is things that scientists do because knowing the angles helps us measure. It's something that architects discuss regarding the stability of structures, for example. So this is a picture of a spider web, but if you look, they can draw this kind of green polygon around the outside, and in blue letters I went ahead and counted, so you can see it's a septagon. It has 7 sides, so n minus 2 would be 5, and 5 times 180 is 900. There's 900 degrees inside this polygon. Over here, this structure is a honeycomb. Bees make honeycomb, but if you looked at this shape, it's very familiar. It's a hexagon with 6 sides. So 6 minus 2 times 180 gives me 4 times 180. Within this shape right here, there are 720 degrees. Again, I'm doing this pretty quickly because it's just examples of applying the idea that we did yesterday. So these aren't regular shapes like the ones that we looked at before, right? But there's just 3 examples, and I went ahead and worked one out. Now you see a lot of these angles are filled in, but now here's an X. How could I solve for that? I don't know what it is. You're right, I don't know what this triangle is, but I can see that this is a polygon, completely enclosed. If I count, there are actually 6 sides. So the sum of all the interior angles is something I can calculate. 6 minus 2 times 180 is the sum of all the interior angles. Well, that means 720 has to equal that sum. And that sum is x plus 125 plus 120 plus 125 plus 110 plus 135. Or 720 equals x plus 615. Subtracting from both sides, I can solve that x equals 105 degrees. And you can do the same thing if you wanted to practice these other 2 shapes. Remember, whenever you see this square, that means it's a right angle, and all right angles are 90 degrees. So you know 3, and you can solve the 4th. And this here is a pentagon. And I could set up the exact same thing. It would just be 2x plus 2x. I can just set up an equation the same way, solving for all the interior angles and then solving for x. Now here is a picture of a cloud system on Saturn, right? And approximately this cloud system is the shape of a regular hexagon. So could I determine the measure of each interior angle of this hexagon? So I made a note here. Regular means all sides and all angles are congruent. So each side is congruent to every other side. Each angle is congruent to every other angle. Okay? So a hexagon has 6 sides and 6 angles. So I know that they're all exactly the same And by applying our formula, n minus 2 times 180, or 4 times 180, I can determine that the sum of all the angles is 720. So if all 6 add to 720, but each one is exactly the same, then I know that each angle would be 720 divided by 6. So I went ahead and worked this example because I wanted to remind you that regular means that all sides and all angles are congruent. Okay. So we've talked about the interior angles. We did a lot with that yesterday, and there was just the one question about the exterior angles. Well, as it turns out, exterior angles are very easy because it doesn't matter what shape it is at all. Any polygon has exterior angles that add to 360 degrees. No matter what shape it is, all of the exterior angles, as long as it's a convex polygon. Convex polygon just means there's no caves. Right? It never goes inside every shape. There's no caves in it. So every convex polygon, all the exterior angles are 360. So if I look at these, I went ahead and solved the green one for us. Let me move this so we can see all the... I'll try. Sometimes it's harder than it seems. Yeah. So find the measures of the exterior angles. Well, if I look at this green one, I know no matter what shape it is, this one happens to be a quadrilateral, it doesn't matter what shape it is, the exterior angles will always equal 360 degrees. Well, I know that 127 plus 91 plus x plus 50 is what all the exterior angles are. So that needs to equal 360. So if I add all the constants, I get 268 plus x equals 360, or subtracting from both sides, x equals 92. So you can apply the formula the exact same way. It just turns out that for the exterior angles, as long as it's convex, they always add to 360. Okay. So let me move this back really fast. I worked this one out because I wanted to show you again. It doesn't look like there's any numbers on this, but actually they are giving us a lot of information. So find the measures of the exterior angles of the polygon. Is what the question says. Find the measures of the exterior angles of the polygon. I got kind of cut off there, but and I can do that because this red square is a measure. It's telling me that's 90 degrees. Now this shape has 5 sides and 5 exterior angles, but it doesn't matter what shape it is. The exterior angles always sum to 360 for any convex polygon. So 360 equals the sum, and I just went ahead and wrote, well, there's 3 of these 90 degrees. 90 plus 90 plus 90 is 3 times 90. And there's an x and an x, so there's 2 x's. So then I can solve it. 360 equals 270 plus 2x. So 2x equals 90 and x equals 45. I don't know how I made those mistakes when I was typing it up earlier, but there you go. Okay. So for this lesson, there's really just the two formulas, n minus 2 times 180, and all convex polygons have exterior angles summing to 360. Okay.